Hi Year 10, this is our third lesson for nonlinear relationships. In this lesson we're going to learn about circles. So far this topic we've covered reciprocal functions and in particular how to draw hyperbolas. And then last lesson we looked at exponential functions. So a circle with centre 0, 0 and radius r has the equation x squared plus y squared is equal to r squared. And this is significantly different to the equations that we've looked at so far. So remember we've looked at y equals mx plus b, which is a straight line, and then we also looked at parabolas like y equals x squared. We've looked at exponentials like y equals 2 to the power of x, and we've also looked at hyperbolas that look like y equals 1 on x. The real difference here is we've got a y squared, and that's what's going to help it become a circle. Now, if we have a look at this circle here, this has got an equation x squared plus y squared is equal to 9. We can see that the radius is 3, and when we square it, we get 9. So that's what goes here. Now, I mentioned that this is a little bit of a strange equation because it's got a y squared in it, and we could make y the subject of that equation, like this. So we'll take the x squared over the other side, it's going to become negative. So y squared is equal to r squared, take away x squared, and then get rid of the square, we do the square root. And don't forget the plus or minus. Now actually what this gives us is the two semicircles. So if we split them out, then this is the top semicircle, and this one's the bottom semicircle. And this is what they look like. So if we've got y is equal to the square root of 4 minus x squared, it will have a radius of 2, center 0, 0, and it's going to be the top semicircle. What do you think this one's going to be? Exactly the same, it's just the bottom half, like that. Now curiously, we could also make x the subject, and that will give us vertical semicircles. So we go through the same process, make x the subject, and the positive square root will be this right-hand side semicircle. It's going to be in the positive quadrant. And the negative square root will be over this side. It'll be in the negative quadrants. Okay, let's move on. If the center of the circle isn't at 0, 0, then we have a more complicated equation. It's going to look like this. A circle with center hk and radius r has the equation x minus h all squared plus y minus k all squared is equal to r squared. Now the r squared is still the same, but instead of x squared plus y squared, we've got in brackets x minus h and y minus k. So let's have a look at this example. This circle has center 1, negative 2, and radius 3. So if I do 3 squared, I'm going to get 9, so that's what goes here. And here I'm going to write x minus 1 all squared plus y plus 2 all squared. And it's written this way with the minuses so that we can easily find the center of the circle by asking what makes 0. What makes 0 here? 1. What makes 0 here? Negative 2. Do you see? Okay, let's try a couple of examples. For the following circles, state the center and the radius. So let's start with the center. We're going to ask ourselves, what makes 0? What makes 0 here? 1. What makes 0 here? Negative 3. There's our center. Make sure you write it in point form. And our radius is going to be the square root of this number, which is 4. Here's another one. What makes 0 here? 0. What makes 0 here? 2. Our center is 0, 2. And the radius is just the square root of 5. And we're going to leave it like that. Now that's all very nice when everything's factorized, but of course they're going to give you a question where it's not factorized, like this one. We're given an expanded equation for a circle and we're asked to find the center and the radius. We want it to be in this form, x minus h all squared plus y minus k all squared equals r squared. And so we're going to have to complete the square, and we're going to have to do it twice. Once for the x's and then once for the y's. So looking at that equation, I want to turn the x squared minus 6x into x minus 3 all squared, and the y squared plus 2y into y plus 1 all squared. So the first thing I'm going to do is rewrite the equation and adjust it slightly so I've got some gaps to complete the square. Alright, do you remember how to do this? I'm going to look at the coefficient of x and the coefficient of y, and I'm going to halve it, square it. Now the coefficient of x is -6, but we don't need to worry about the negative because it's going to square out. So I'm just going to look at the 6. Half of 6 is 3, 3 squared is 9. That's what goes in here. Coefficient here is 2. Half of 2 is 1, 1 squared is 1. Now of course I can't just introduce numbers into an equation because I've changed it. I'm going to have to balance it up by putting these numbers on the other side. Have a look at that and make sure that makes sense to you. Alright, I'm ready now to write it as x minus 3 all squared and y plus 1 all squared. So this part here is x minus 3 all squared. This part here is y plus 1 all squared. And over here we've got 25. And there we are, we're fully factorized. Alright, center is 3, -1, and the radius is 5. Here's another one. Find the center and radius of the circle given by the equation x squared minus 2x plus y squared plus 4y plus 1 equals 0. So we're going to rewrite it with a gap here and a gap here, and I'm also going to move this plus 1 over the other side, like this. Alright, let's complete the square. Coefficient of x is -2, but I don't need to worry about the negative. Half of 2 is 1, 1 squared is 1. Coefficient of y is 4. Half of 4 is 2, 2 squared is 4. Balance it up. Okay, let's rewrite it. So x squared minus 2x plus 1 is x minus 1 all squared. It's always the square root of this number here. Y squared plus 4y plus 4 is y plus 2 all squared. So there it is, factorized. Center is 1, -2. Radius is 2. Okay, last example. Find the center and radius of the circle x squared plus y squared minus 8y equals 5. This one's slightly different because we don't have to complete the square for the x squared. Can you tell why? There's no term in x. So this one's okay as it is. We just have to complete the square here. So let's put a gap, look at the coefficient of y, which is 8, and we want to halve it, square it. So half of 8 is 4, 4 squared is 16. Whatever we do to one side, we need to do to the other. Okay, so this is just going to be x squared. This will be y minus 4 all squared, and this is going to be 21. Okay, let's get the center. It's going to be 0, 4, and the radius is going to be the square root of 21. Okay, one final note. When we're completing the square with circles, there's never ever going to be a leading coefficient greater than 1, like this. See how the coefficient of x squared is 2? Now I know you've completed the square before when there's a leading coefficient greater than 1, but this is never going to happen with a circle because this actually isn't a circle. This is an ellipse, so you don't need to worry about it. So in some senses, it's a little bit easier. Okay, that's it for this lesson. In our next lesson, we're going to look at higher powers of x.